Here's the second lesson on transformations of sine and cosine functions. In this lesson, I'll give you the graph of a sinusoidal wave, and I'll teach you how to write its equation as both a transformed sine and transformed cosine function. And we can do that if we can figure out the a, k, d, and c parameters that transform the function. Let me give you a quick overview of how we can find all four of those parameters based on the graph. Let's write the general rules to start off with. If I want the a value can correspond exactly to the amplitude of the function. And if I want the amplitude, I know amplitude is half the distance between the max and the min points. I can visualize that by this line right here, which is the distance from the midline to the max or from the midline to the min. I can calculate that by doing the difference between the max and min values and then cut it in half. So to calculate the amplitude, which I can use for the a value of my transformed function, I can do the y-coordinate of a maximum point minus the y-coordinate of a minimum point, which will give me the whole distance between the max and the min, but I only want half of that, so I need to cut that in half. So max minus min over 2 will give me the amplitude of the function, which I can use for a. And if I want the k value, remember k does horizontal stretching and compressing of a function. To calculate k, I can do the period of a normal sine or cos function, which is 360 degrees, and then divide that by the period of the function that I have the graph of, and that will give me the proper value of k that will stretch or compress the sine or cosine function appropriately. And remember, how can we find the period of a function? Well, that's just the horizontal length of one cycle. So I've got one cycle of this function mapped off in blue. Its horizontal length I can see is 360. But we don't have to map off right at a point that's on the y-axis like I did there. We can map off between this max point, I can make that the initial point, and then the end of the cycle would be once it gets back to the next maximum point. The horizontal length of that section is also 360. And next, let's actually talk about c next. C is the vertical shift of the function, or we can visualize that as the middle of the function, which I did by putting this purple dotted line horizontally through the middle of the function. I can find that c value by doing the maximum point minus the amplitude, or I could find that midline just by averaging the max and min points. So I could do max plus min and then divide it by 2 to find their average, to find the middle of the two of them. So I'll write those two formulas here. We could find c by doing the max minus the amplitude, and amplitude is always equal to the absolute value of a, so I'll write that there. Or we could find c by averaging the max and the min y values, and we do that by adding them and dividing by 2. Now, if we are writing a transformed sine or cosine function that would match this wave, they would have the exact same a, k, and c values, but their d values, the horizontal shift, would be different. Let me show you in Desmos what I mean. So I'll have Desmos graph a cosine function, and notice right on the y-axis is a maximum point. I'm going to label that the d value for cosine, because if I change the d value, which will cause a horizontal shift, you'll see that that maximum point is no longer right on the y-axis. If I make d 45, notice the x-coordinate of that maximum point is now 45. So the x-coordinate of a maximum point corresponds to the d value of the cosine function. And you might say, well, why are we using the x-coordinate of that maximum point? Why not the maximum point that's at 405 or negative 315? Well, you could use either of those as well, and it would give you the exact same graph. Watch, if I make the d value 405, the graph didn't shift at all, meaning that it's an equivalent function. So just use the x-coordinate of any maximum point, and that will be the d value for a cosine function. But what about a sine function? I'll have Desmos graph a sine function, and I'm going to label the point that's right on the y-axis, and I'm going to call it the d value for sine. Notice that point is right in the middle of a rising line for sine. And we call that point the rising midline because it's in the middle of a rising line. If I pay attention to where that point has moved, that rising midline point, its x-coordinate corresponds to the d value. So if I make d 45, the x-coordinate of a rising midline is now at 45. So if we were trying to write a cosine function, we just look at the x-coordinate of a maximum point. So this point right here, its x-coordinate becomes the d value. But if we were trying to write a sine function, what we would do is look at the x-coordinate of a rising midline. Remember, a rising midline is a point where a rising part of sine intersects with a midline. So this point right here, its x-coordinate would be the d value for a sine function. And there's actually a relationship between these 2 points. The horizontal distance between those 2 points is always 90 divided by k. I should actually write it's 90 divided by the absolute value of k. And let me show you what I mean by that in Desmos as well. I've got that green bar at the top showing you the horizontal distance between the rising midline and the max. Notice that it's 90 degrees. But if I change the k value to horizontally stretch or compress the function, that's also going to horizontally stretch or compress the distance between the rising midline and the max. So for example, if I make k 2, that would do a horizontal compression by a factor of 1 over 2. So the horizontal distance between the rising midline and the max is now only 45. So we can calculate that distance just by doing 90 divided by the absolute value of k. And knowing that relationship might be helpful. For example, if you knew the d value for sine but didn't know the d value for cos, you could find that d value for cosine by using the d value you know for sine and then adding 90 over the absolute value of k. Right? If we knew this point's x-coordinate, if we added 90 over the absolute value of k, it would give us this point's x-coordinate. And also, if we knew this point's x-coordinate and subtracted 90 over the absolute value of k, we would get the x-coordinate of a rising midline. So the d value for sine, we could take the d value for cosine, which is the x-coordinate of a max, and subtract 90 over the absolute value of k. So now that you know all of these formulas, let's go ahead and try and write both a sine and cosine equation for the graph of this function. If I want to write the equation of this graph, I'll start by finding the a value, which corresponds to the amplitude of this function. And I can find the amplitude by doing the y-coordinate of the max, and then subtracting the y-coordinate of the min, and then dividing by 2. That will find me half the distance between the max and the min. And the y-coordinate of the max is 3, and the y-coordinate of the min is -1. So to find a, I have to do 3 minus -1, and then divide it by 2. And then evaluating, 4 divided by 2 is 2. So my a value, my amplitude of the function is 2. Next, we can find the k value by doing 360 degrees divided by whatever the period of this function is. The period of this function, I'll highlight one cycle of this function in red here. Notice I started at a maximum point and the cycle will finish at the next maximum point. The horizontal length of that cycle is the period of the function. And its horizontal length, well, the cycle started at 10 and finished at an x-coordinate of 20, the distance between 10 and 20 is 10. So the period of this function is 10. 360 divided by 10 is 36, so my k value must be 36. Next, we'll do the c value, which is the midline of the function. Since I know it's in the middle of the function, I can find the middle of it by just averaging the max and the min values. So I'll add the y-coordinate of the max and the min together and then divide by 2 to find the average of them. That would be 3 plus -1 divided by 2, which would be 2 over 2, which is 1. Notice if I drew a horizontal line through 1, that is the midline of the function. And the distance from that midline to the max, this distance right here, that's the amplitude of the function. And lastly, let's do the d value, which would be different depending on whether we're writing a sine or a cosine function. And we want both, so I'll find the d value for cosine and the d value for a sine function. To model this graph with a cosine function, I need to know the x-coordinate of a max for my horizontal shift. Notice I have a maximum point at an x-coordinate of 0, and again at 10, or 20, or 30. Because the period of this function is 10, there's going to be a max every 10 units. We can use the x-coordinate of any of those maximum points. Typically, we use the one closest to the y-axis, so I'll use this one here, which has an x-coordinate of 0. So the d value for cosine is 0. And if I want the d value for sine, there's an infinite number of possibilities we could use, but I'm looking for the middle of a rising line. Well, here's a falling line, here's a rising line, and the middle of it would be where it intersects the midline of the function, which is right here. Its x-coordinate will be the d value for sine. Well, my scale appears to be going up by 2.5, 2.5, 5, 7.5, 10. So the x-coordinate of this point is 7.5. And then I can use all of those parameters to write my two equations. I'll start by writing my cosine function, and then also my sine equation, where the only difference is going to be the d value. And those equations are equivalent to each other. They both model the graph of this function. You could test them both out to make sure they're both right. We could pick a point that we have on our function. This point right here, for example, is the point 20, 3, meaning if I sub 20 in for the x's into either of those two equations, it should be equal to 3. And you could check a bunch of points on the function to make sure both of those equations equivalently model the graph. Now moving on to part B, let's represent this sinusoidal wave with both a sine and cosine function as well. We'll have to find all four parameters, a, k, d, and c. Let's start with the a parameter. To find the value of a, I can just find the amplitude of the function, which is half the distance between the max and the min. Well, the maximum value is up here at a y value of 5, and the minimum value is down here at a y value of 1. So to find the amplitude, I find the difference in the y coordinates of the max and the min. So I'll do 5 minus 1, and then I have to cut that in half. That gives me 2. So my amplitude of the function is 2. Next, I'm actually going to calculate c, which is the horizontal midline of the function. It's the vertical shift value, and I can find that just by finding the middle of the max and min values. So the average of them, which I can get by adding them and dividing by 2. So the y coordinate of the max was 5, the y coordinate of the min was 1, so if I add those and divide by 2, I get the middle of the function. 6 divided by 2 is 3. Notice if I were to draw a horizontal line through the line y equals 3, that would exactly divide the function in half horizontally. And next, let's calculate k, which we can calculate by doing 360 divided by whatever the period of this function is. Remember, period is the horizontal length of one cycle. If I were to try and map off one cycle between maximum points, that might be a little challenging because I don't know the start and the end of this. I don't know the x coordinates of these maximum values. So I need to choose a different starting point other than the max. The min's not going to work either, but if I choose a rising midline as a starting point right here, and then map off a cycle that goes to the next rising midline, I'll be able to see the horizontal length of that cycle. So let me actually outline that section in green, and the period is just the horizontal length of that cycle. The cycle starts at an x value of 30, and it finishes at an x value of 120. The distance between 120 and 30 is 90. So to calculate k, I do 360 divided by 90, which is 4. And then lastly, we have to find the d parameters, the phase shift. And remember, those are going to be different depending on whether we're doing a sine function or a cosine function. And we want both. So I'll need the d value if I'm doing a sine function, but also the d value if I'm doing a cosine function. And remember, the d value for a sine function is just the x coordinate of a rising midline. Well, here's a rising line. Here's a midline. Where they intersect is at this point right here. The x coordinate of that point, if I look down here, would be 30. So I'll just put this orange point on the graph so you can visualize it. And that point right there, its x coordinate is the d value for sine. So the d value for sine is 30. And the d value for cosine would just be the x coordinate of a maximum point. But we don't know the x coordinate of that point. I can see that it's less than 60, but by how much? Well, hopefully you remember the relationship between the x coordinate of a rising midline and the x coordinate of a max. They're always 90 over the absolute value of k apart from each other. So if I wanted the x coordinate of the max, I could take my d value for sine and add 90 over the absolute value of k. And we know the d value for sine, it was 30, and the k value was 4. 30 plus 22.5 would be 52.5, which means the x coordinate of this maximum point up here, we can use as the d value for cos, it was 52.5. And now I can write my final two answers. I'll start by writing the sine function, and then for the cosine function, the only difference is going to be the d value. And both of these equations are equivalent to each other, and they both define the function that we have the graph of up here. Let's move on to part C. Once again, we'll describe this wave with both the sine and cos function. Let's start by finding the a value. The a value corresponds to the amplitude of the function, and to find the amplitude, I'll have to find the difference in the max value and the min value, and then divide it by 2. Well, the y-coordinate of the max I can see is 3, and the y-coordinate of the min is down here at -5. So when finding the amplitude, I'll do 3 minus -5, and then divide that by 2. That gives me 4. So my amplitude of this function is 4. Next, let's find the c value. I can find the c value just by finding the average of the max and min. So I'll do 3 plus -5, and then divide by 2. And that gives me -1. And notice the c value corresponds to the vertical shift, which is why that's where the middle of the function is going to be. Drawing a horizontal line through y equals -1 divides the function in half. Next, we will find the k value, which we can calculate by doing 360 divided by whatever the period of the function is. To find the period, that's the horizontal length of one cycle. I'll map off between maximum points so you can visualize one cycle. I'll do that in green. Now, just the horizontal length of that section is going to be the period of the function. Well, the cycle starts at an x value of 90 and ends at an x value of 210. So the horizontal length of one cycle would be the difference between 210 and 90. And that difference is 120, which means the k value is 3. There's been a horizontal compression by a factor of 1/3. Lastly, we need the d value for both cosine and sine. The d value for sine, the horizontal shift for sine, is just the x-coordinate of where a rising midline is. Well, that would be the x-coordinate of this point right here, which is 60. So our d value for sine is 60. And then the d value for cosine is just the x-coordinate of a maximum point. Well, I see a bunch of maximum points. We could use the x-coordinate of any of these. And notice how far apart are those x-coordinates of the maximum points? Well, they're all 120 degrees apart because that's the period of the function. So it wouldn't matter which of them we use. I'll just choose this one here. The x-coordinate of that point is 90. And now I can write both my transformed equations. They're going to share a, k, and c values, but have different d values. And there we have both of the equations that are equivalent to each other and both represent this function. Example 2 says, a sinusoidal function has an amplitude of 3 units, a period of 180 degrees, and a maximum point at 0,5. Represent the function with an equation in 2 different ways. Well, I know 2 different ways. I could use a sine function and a cosine function to represent it. Let me start by seeing if I can make a rough sketch of this function based on what this tells me. It says that there is a maximum point at the point 0,5. So if it ever gives you a point, that's the easiest thing to plot first. I'll plot the point at 0,5. And then it also says the period of this function is 180. So I know if I move 180 to the right or to the left, the function is going to be right back at the same height. It's going to be right back to its maximum value. And because the function has an amplitude of 3, well, amplitude is half the distance between max and min, which means if I move 3 units down from the max, that will bring me to the midline of the function. So let me actually draw my c value, my midline, right here at a y value of 2. And then if I moved another 3 units below the midline, that would bring me to the minimum of the function. But when is the minimum going to occur? I know the minimum is going to be at -1, and it's going to happen halfway between these maximum values. So between -180 and 0 is -90. So it will be at a min value when x is -90, and then 180 degrees to the right of that again, and then 180 to the right of that again, and so on. And then this function will hit the midline when we're halfway between the max and min values. So halfway between 0 and 90 is 45. So it'll be at the midline when x is 45. And then again at 135, and so on. And then connecting all these points will give us a rough sketch of what this function looks like. And now to write the equation, I just need all of my parameters, a, k, d, and c. It's actually going to be quite easy to calculate these because the question tells us the amplitude is 3, so I know my a value is 3. It tells me that the period is 180, and I know I can get the k value by doing 360 divided by the period. So 360 divided by 180 is 2. To find the c value, that's just the midline of the function, which can be calculated a couple different ways. We can do the maximum value of 5 and then subtract the amplitude of 3 to see that the c value is going to be at 2. Or we could just average the max and min values. The max is 5 and the min is -1. If I average those by adding them and dividing by 2, I get a c value of 2. And then the d value is different depending whether we're doing cosine or sine. D value for cosine is the x-coordinate of a max. There's a maximum point at an x-coordinate of 0. So the d value for cosine, I can use 0. And the d value for sine, I need the x-coordinate of a rising midline. How would I use this one? The x-coordinate of that point is halfway between negative 90 and 0. So it's at negative 45. And now I can write both equations. And let's try this type of example one more time. Example 3 says we have a sinusoidal function with an amplitude of 5, a period of 120 degrees, and a maximum at 0,3. Represent the function two different ways. So once again, we'll use a sine and a cosine function. Let me start by plotting the maximum at the point 0,3. And then because the period is 120 degrees, I know it'll be back at the maximum if I move 120 to the right or 120 to the left. Because the amplitude is 5, I know I would have to move down 5 units from the maximum point, and then I would be at the midline of the function. So I'll draw the midline at negative 2, which corresponds to the c value, so I'll write that right now. C value is negative 2, and I got that by doing the max minus the amplitude, which equals negative 2. And because amplitude is half the distance between max and min, that would mean if I go 5 units below the midline, that'll bring me to the minimum point. So there'll be a minimum point at a y value of negative 7. And the min's going to happen horizontally halfway between the max values. So it'll happen at x values of negative 60 and 60. And any increment of 120 degrees to the left or right of those. And then I'm going to plot points on the midline of the function as well. The function's going to hit the midline horizontally halfway between the min and max points. And then I'll connect. And now let's state the other three parameters. A, the question gives us. It says the amplitude is 5. K, 360 divided by the period of the function, which the question states is 120 degrees. So 360 divided by 120, our K value is 3. And then the D value for cosine would be the x-coordinate of a max, which I see the x-coordinate of that point is 0. And the D value for sine is the x-coordinate of a rising midline. The x-coordinate of this point, it appears, is going to be negative 30, halfway between negative 60 and 0. So the D value for sine is negative 30. And if you wanted to be sure, you could calculate this D value for sine by just subtracting 90 over K from the D value for cosine. So following this formula, d sine equals d cos minus 90 over the absolute value of K. The D value for cos was 0, and the K value is 3. And we have 0 minus 90 over 3, that's 0 minus 30, which is negative 30. And now with all of those parameters, we can write both equations. There you go. Now that you have both of those equations, you can go to Jensen Math and try out the practice questions that go along with this section.
Jensen Math.